Welcome to the Bare Metal Cyber Security Plus podcast. This series helps you prepare for the CompTIA Security Plus exam with focused explanations and practical context. For a companion study guide, check out the Achieve CompTIA Security Plus 701 Exam Success by Dr. Jason Edwards. It is the most concise and complete Security Plus guide on the market, built for busy professionals who want to pass the exam fast and on their first try. You can find this book and others at cyberauthor.me. In the last episode, we explored how to validate vulnerability scan results and make smart decisions about which findings deserve the highest priority. But vulnerability analysis and prioritization are not just about confirming what exists. They are also about understanding how vulnerabilities are scored, how they are classified, and how your specific environment changes the level of risk. In this episode, we dive deeper into scoring and classification systems, including the Common Vulnerability Scoring System and the Common Vulnerability Enumeration Framework. We will also look at how exposure factors and environmental variables play a crucial role in vulnerability management. Let's begin with scoring and classification systems. When organizations receive a vulnerability report, it often includes a severity rating or numerical score. This helps security teams understand the potential impact of the vulnerability and prioritize their response. The most widely used framework for this is the Common Vulnerability Scoring System, often abbreviated as CVSS. The Common Vulnerability Scoring System is a standardized method for rating the severity of software vulnerabilities. It produces a score ranging from 0 to 10, where 0 means no risk and 10 represents the most critical vulnerabilities. The score is calculated using a formula that considers multiple characteristics of the vulnerability, grouped into 3 metric categories: base, temporal, and environmental. The base metrics describe the inherent properties of the vulnerability. These include the attack vector, the level of access required, the complexity of the attack, and the impact on confidentiality, integrity, and availability. For example, a vulnerability that allows remote attackers to execute code without authentication would score much higher than one that requires local access and user interaction. The temporal metrics reflect factors that can change over time, such as whether exploit code is available, whether the vendor has released a patch, or how confident analysts are in the report. These help adjust the score based on current threat conditions. Finally, the environmental metrics allow organizations to customize the score based on their specific context. This includes the importance of the affected system, the impact on the organization's operations, and the presence of mitigating controls. By adjusting these variables, security teams can better assess which vulnerabilities pose the greatest risk to their environment. Let's walk through an example. Imagine a web application vulnerability has a base score of 8.8. It is remotely exploitable, has no required authentication, and impacts both data confidentiality and availability. Initially, this looks like a high priority issue, but if the application is internal only, protected behind a firewall, and mitigation controls are already in place, the environmental score might be lowered to 5.4. This context-sensitive scoring helps teams focus their attention where it truly matters. In parallel with the Common Vulnerability Scoring System is the Common Vulnerability Enumeration Framework. The Common Vulnerability Enumeration provides a unique identifier for each publicly disclosed vulnerability. These identifiers take the format CVE, followed by the year and a number. For example, CVE-2024-03971. The Common Vulnerability Enumeration is managed by the MITRE Corporation and supported by the National Cybersecurity Federally Funded Research and Development Center. Its primary goal is to provide a standardized naming system for vulnerabilities. This ensures that when different organizations, tools, or vendors refer to a vulnerability, they are all talking about the same thing. Each Common Vulnerability Enumeration entry includes basic details such as the affected products, a brief description of the vulnerability, and references to additional resources or advisories. The Common Vulnerability Enumeration does not assign severity scores itself. Instead, it works in conjunction with other systems like the National Vulnerability Database, which adds CVSS scores and more detailed metadata. The benefit of the common vulnerability enumeration is that it enables consistent tracking, reporting, and discussion of vulnerabilities across the entire cybersecurity ecosystem. Whether you are reading a vendor bulletin, reviewing a scan report, or checking a threat feed, the presence of a common vulnerability enumeration number helps you quickly locate and understand the issue. For instance, if a vulnerability scanner flags a critical vulnerability in your infrastructure, the report will usually include the common vulnerability enumeration number. You can then look it up in the National Vulnerability Database to find out if a patch exists, whether exploit code is available, or if other organizations are seeing the same issue. This centralized reference system greatly improves communication and coordination in vulnerability management. Now let's shift to assessing exposure and environmental factors. Even with a common vulnerability scoring system score and a common vulnerability enumeration ID, not all vulnerabilities pose the same level of threat to every organization. Exposure factors describe how likely it is that a vulnerability will be exploited in your specific environment. These include system visibility, user behavior, network architecture, and the presence of compensating control. For example, a database server with a known vulnerability might be rated as high severity in general, but if that server is behind multiple layers of firewalls, isolated from the internet, and only accessible to a small number of trusted administrators, the actual exposure is much lower. Conversely, a lower severity vulnerability on a publicly accessible web server might present a greater real-world risk due to ease of access and visibility to attackers. Another important exposure factor is the value of the asset. A vulnerability on a system that holds sensitive personal information, payment card data, or intellectual property carries more weight than the same vulnerability on a test server or lab system. This is why asset criticality and business impact are essential components of vulnerability analysis. Environmental variables also come into play when deciding how to respond. These include organizational policies, operational constraints, third-party requirements, and even cultural or staffing factors. For example, an organization that follows strict compliance regulations may be required to remediate certain vulnerabilities faster than another organization without the same obligation. Or a smaller business with limited IT staff may have to schedule fixes more carefully to avoid disrupting operations. These variables are also considered in risk acceptance decisions. Not every vulnerability must be immediately patched. Some may be accepted temporarily if the risk is deemed low or if mitigating controls are in place. But this decision should be based on a careful assessment of exposure, impact, and likelihood, not just the common vulnerability scoring system score alone. Let's explore a practical scenario. A company discovers that one of its internal tools relies on a library with a published vulnerability. The common vulnerability scoring system, base score, is 7.5. However, the system is isolated, the vulnerable function is not used in their implementation, and access is tightly restricted. The team decides to monitor the situation and upgrade the library during the next scheduled release cycle. This is a case where understanding exposure and environment allows for a reasoned, risk-based response. In another case, a university's admissions system is found to have a moderate vulnerability, but it is publicly accessible and experiences high traffic during enrollment periods. Due to the exposure level and potential reputational damage, the issue is escalated and patched within 24 hours, even though the base score is not the highest. Again, environmental context changes the priority. To summarize, vulnerability scoring and classification systems help standardize and streamline analysis. The common vulnerability scoring system provides a detailed, structured score that reflects severity and can be customized for your environment. The common vulnerability enumeration framework gives each vulnerability a unique, trackable identity that supports consistent communication. Exposure factors and environmental variables add essential context, helping teams make risk-based decisions tailored to their assets and operational needs. As you prepare for the Security Plus exam, expect questions that test your understanding of how vulnerabilities are scored and classified. You may be asked to interpret a common vulnerability scoring system score, identify the role of a common vulnerability enumeration identifier, or evaluate a scenario where exposure factors change the prioritization of a vulnerability. Be sure to review terms like base metrics, asset criticality, and compensating controls. They are common in both multiple choice and performance-based exam questions. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.